All right, the first example we're going to look at. A faculty advocacy group is concerned about the amount of time teachers spend each week doing schoolwork at home. It's a lot, trust me. A simple random sample of 56 teachers has a mean of 8 hours per week spent working at home after school, with a standard deviation of 1.5 hours per week. Construct and interpret a 95% confidence interval for the mean number of hours per week all teachers spend working at home after school. So we want to take our sample of 56 teachers who work an average of 8 hours per week in addition to their standard 40 hours in the classroom, with the standard deviation of 1.5 hours per week. And we want to construct and interpret a 95% confidence interval. And we do have this nice little bonus here of the mean number of hours per week. Another indicator that this would be a mean, if it was not obvious from the word mean and standard deviation, is they're looking at the amount of time teachers are spending working from home each week, in addition to the work that they do for work at school. So this is a question of how much time do you spend? How much, that's going to be numerical. So a 95% confidence interval, so that's our 95% confidence level, meaning 95% of my curve is shaded. That's the middle 95%. So 5% of my curve is unshaded. So 5% is our alpha. The rest of our values here, we have 56, 8, and 1.5. So 56 is the random sample of teachers they took, so that's our sample size N. The mean was 8 hours per week, so that's the mean of the sample, so that's X bar. And the standard deviation of 1.5, that's a sample standard deviation. Everything for this is based off of the sample of 56 teachers. So the first thing I'm going to do, because I already have my X bar and my S, the first thing I'm going to do here is find the T alpha over 2. If I didn't have these two values, that would be the first thing I would do. If I had data instead of being given these numbers, that would be the first thing I do. But since I was given X bar and S, I'm going to go straight into finding T alpha over 2, finding that critical value. And we're going to use Excel for this. So we have 5% for our alpha, which is 0.05. So alpha over 2 is 0.05 over 2, which is 0.025. So this is what I'm going to plug into Excel. And now we're looking for a T-score, not a Z-score. So I can't use norm.s.inverse. I'm going to use T.inverse. And T.inverse is going to require two things to be entered. It needs the probability, so that's the 0.025, and the degrees of freedom. And remember, degrees of freedom is equal to n minus 1. So we surveyed 56 teachers. So our degrees of freedom is 55. Recall, the T distribution is different depending on your sample size. Every sample size produces a slightly different t distribution. So by putting the comma 55, we are telling Excel which t distribution it needs to look at. So t.inv 0.025, 55. Negative 2.0040. Just like we did before, we're going to ignore this negative. We want our t alpha over 2 to be a positive number. So my t alpha over 2 is 2.004. I don't need that 0 at the end. It does nothing. So I'm not going to write it. So now I just need to plug this into my confidence interval equation. Which is x bar plus and minus that t alpha over 2 value times s over the square root of n. So my x bar is 8 plus and minus 2.004 times 1.5 over the square root of 56. So I'm going to find the margin of error first, which is the second half. And you can do this actually all at once. If you just throw parentheses around this fraction, then you don't have to do those pieces separately. So 401693647. So then I'm going to add and subtract 8 from this margin of error. So when I add 8, I get my upper bound, which is 8.4017. And when I subtract, I get my lower bound of 7.5983. So then we can go ahead and use Excel. We'll use Excel to check this and make sure we didn't mess anything up. Ignore. I don't know what it's trying to open. But just know anytime you are not explicitly told to do something by hand, which is what we just did, you can go ahead and go straight into this Excel file. So we just did this by hand. Let's go into Excel and make sure we did it right. So here's our proportion one. If I keep scrolling, I will find one for the means. Also remember, the first page of this document has a table of contents that you can use to quickly navigate to any of the workbooks in here, or the worksheets rather. And it just so happens all of the information I have in here already is the information we needed. So X bar is 8, S is 1.5, N is 56, our confidence level is 0.95. I did not do that intentionally. Our critical value 2.0040. 7.5983, 8.4017. So Excel gives you your upper and lower bounds right away. All you have to write down are the upper and lower bounds. So then you can go straight to the interpretation. Wait, that's not how you spell interpretation. Interpretation. So if I'm going to interpret this, I would say we are 95% confident. So restating our confidence. That the mean number of hours teachers spend doing schoolwork at home. So restating what it is we were looking at is between 7.5983 and 8.4017 hours. You could use average instead of mean here. Make sure that you put units on your answer because everything we're looking at will have a unit for it. Also, another thing, it's a really little thing, and it makes more sense when we read it. Put your lower bound first and then your upper bound. It just flows better as you read the sentence. Okay? Write your sentence, read your sentence back to you, make sure it makes sense, make sure it sounds good. If you read it and you're left going, what did I write? You should probably rewrite it. Because I'm probably going to say, what did you write? So there is the confidence interval for a mean first example.